got my own timer because I need to stay on track because I have a lot to say. So, oh, there it is. I'm Michael Hoffman with Object Theory. Did I make it just go forward all these ways? I'm not quite sure it started at the end or near in the middle. Excuse me for a second here. Oh, you're getting like a sneak preview and get to see everything I'm going to say. All right, so I'm here to talk about mixed reality use cases and challenges. I'm going to be focusing more on use cases, but there are a lot of challenges that I'm outlining. I'll point out some of the main ones that clearly I think almost everybody in this room knows exist and are potentially challenged with in attempts to deploy solutions on mixed reality. So I'm one of the co-founders of Object Theory. I was on the HoloLens team at Microsoft prior to founding Object Theory, and we're now a Microsoft partner. So we're building solutions not only for Microsoft, but a lot of companies out there that are deploying mixed reality. And this is not just HoloLens. We're also doing a lot of iPad and other deployments. We're seen as a trusted advisor that helps with both the strategy part and the implementation part. So yeah, we've delivered about 30 projects. And one of the interesting things is that I'm going to be talking about 18 use cases. And when building this library of use cases, I just had this realization that we've already delivered 11 of them, at least in POC form, some of them in pilot form. So it's kind of cool that we've been had the opportunity to cover a lot of ground. So the first thing I'm going to talk about is why mixed reality. I mean, this audience, I think, obviously you have been exposed to this a lot, but this is a pretty good catalog that I like to go through of why mixed reality is important. I mean, we talk a lot about hands-free. I think that one is obvious. Then shared 3D context is where this whole journey began for us with CDM Smith. They have a lot of challenges with communications around three-dimensional problems. So to be able to have 3D context is really invaluable in making the connection between what one person is talking about and what the other person is trying to consume. So here's the one that is really exciting to me, stereoscopic vision. One of our clients early on in our company gave us just a LiDAR scan of their office. LiDAR scan is just these billion points of light of their entire office. And we put it on a screen, 2.5D, where you rotate something on the screen. You think you're seeing everything. And we thought we're seeing everything. We're seeing monitors and chairs and desks and a printer on a credenza. It's like, of course you're seeing everything. And this is what engineers and CAD designers, this is what they do all the time. They're looking at stuff on the screen, thinking they're seeing everything. We didn't even have the pre-release HoloLens yet at that point, so we put it on Oculus. And we walked in this thing full scale. It was unbelievable how much more your brain can understand when it's stereoscopic. Same points of light, literally points of light of the right color. And we were seeing like a lightsaber over here and stapler over here. There was a Lego mug. You could tell exactly what was on the poster. It was unbelievable. And this was when I knew that this is going to revolutionize absolutely everything. And it just was exciting to have that confirmation personally, because we're wired to understand our world stereoscopically. Everything about how we experience our world is somehow linked to stereoscopic understanding. And that goes for audio too, by the way. So I think most of the rest of these are fairly obvious. True scale is really important. Even AR doesn't necessarily give the exact sense of scale of something. These new mixed reality devices like HoloLens and Magic Leap definitely let you see something at exactly the scale that's going to be at, and let you experience the space at exactly the scale it's going to be at. 3D sound, as I mentioned before, we also comprehend much better with 3D sound, knowing where sounds are coming from. It gives you more context. Data visualization. We deal all the time, and especially anybody that's in an analytical field, with trying to comprehend really, really complex data. Sometimes it's 10, 20, 30 dimensions of data, and you're just trying to put everything you can into how do you understand, how do you comprehend really complex data. And again, stereoscopic vision helps you do data visualization of things that you've never been able to do before. High fidelity 3D objects. Again, this is like experiencing something that doesn't exist yet is really valuable, and reducing the dependency on 3D printing and 3D printing plus painting, et cetera. And then finally, 3D environments. We actually, again, understand our world spatially. If you are told how to get somewhere versus having experienced how to get somewhere, you're going to remember it a lot better. So those are just kind of the family or gamut of reasons. There probably are others that I haven't thought of, but these are the ones that we cataloged and used a lot, and trying to make sure that whenever we deliver something to a client, that we're finding real value. All right, so the meat of this, and you have to move really fast because I have a lot to cover. So I'm going to post this whole presentation online. There's a lot of words on there. I'm not going to actually speak to the words on there. If you feel desperate to get all this content, don't worry, it is available after the fact. These are the 18 use cases that we've identified. I'm not going to call each one up because I'm going to talk about each one. But we're not finding that many more. If you have found other use cases that we haven't identified, please let us know. We've talked about 1,000. We've had easily 1,000, 2,000 conversations with clients, and we keep looking for the patterns. And these are the patterns that we've seen, these 18 patterns. So the first one, remote collaboration. We as a company have done a lot of focus in remote collaboration. We started building that out for our first client, CDM Smith. And since then, we've been investing in our Prism platform, which I think about 3 weeks, we're going to release Prism 2. So we're very excited about that. Look for that on the Microsoft App Store. So the remote collaboration is about, and this is an interesting one because remote collaboration itself kind of isn't a use case. It is an amplifier of other use cases. Anything that you want to have a conversation around, if you can know that I'm looking exactly at that spot, or you can know that I'm over here and another colleague is over there, and you can be anywhere in the world. You will show up as avatars if you're not in the same physical space. You're getting a lot more context than you ever do in a video conference call or screen sharing. In screen sharing, you're always not quite sure whether the other person comprehended exactly what you're talking about. And with 3D, if you haven't experienced using even gaze for that, it's actually quite powerful to really, really understand what everybody in the conversation is talking about. So some of the challenges, and this is almost across the board, is geometry complexity. Remote collaboration without something interesting to talk about isn't really that useful. So you have to get something interesting in there. And we're all, especially in battery-powered devices, challenged with geometry complexity. Product design. Product design has an interesting challenge across the board. You're almost always inventing something that doesn't exist yet. Maybe it's the next version of something, so you at least have a starting point. But to actually visualize that something that doesn't exist is really hard. So there's a lot of 3D printing going on. One of our clients, L'Oreal, they actually 3D print and then they paint. And it's actually quite expensive, and it takes longer. So it takes longer to go to market to do these iterations and actually get that product out faster. So one of the big opportunities is to actually show the physical product in its form. One thing we did is actually take a 3D print and actually track a hologram to the 3D print, so you can say, try it in blue, try it in yellow, try it in Spanish, try it in German. And it lets you have a really viscerally realistic experience of a product that doesn't exist yet. It's pretty powerful. Some of the challenges here, color matters. We get this feedback a lot from our clients. Current devices aren't calibratable like you can calibrate a monitor. So you have this challenge of it's mostly what you're going to put on the market, but it's not quite there yet. So it needs to be complemented with other ways to deal with color. And that's just one of the minor challenges that we're facing right now. The other is material and shader complexity. It's one thing to get all the materials right in a CAD system. It's another to actually get them into a HoloLens in real time without having to jump through hoops to do that. Annotated environment. I love this one. This is our world these days is filled with sensors, and it's getting more and more filled with sensors. We actually went to a wastewater treatment facility that CDM Smith had a part in building. And the thing that really struck me was the fact that it was a 90-acre property. We go down these corridors with 10, 20, 30 pipes, color-coded, big pipes, little pipes. Not a single person in sight, nothing moving. All you hear is the hissing noise of water in those pipes. And yet, there are hundreds, actually probably thousands of sensors going into a SCADA system and collecting all this data. There's one room in that 90 acres that has 10, 15, 20 monitors, and they've got 2 or 3 technicians, and they're monitoring the health of the whole system. Just imagine, they're going to call, if something goes wrong, they're calling a technician to go out there and explore what the problem is. That technician is going into that completely empty, blind environment with none of the data. They're calling on the walkie-talkie, they're making phone calls, they're looking up on their tablet, information on their tablet. The data is not available where it belongs. So I'm really excited about this one because the future is you always have access to the data where you need it in your world as you do your job. I'm really, really excited about this. It does have some challenges today. Some of these good use cases are outdoors. Some of these use cases are in massive facilities where something like a current-gen HoloLens can't know that I'm here, and then next minute I'm going to be 10,000 feet away or whatever. That's all fixable. We do a lot of tricks across the board to deal with some of the current challenges. In some ideal future, you don't have to compensate because it's all been figured out and systemized. We're just not, as an industry, quite there yet. Premium selling. I love this one because I actually got to go to Blue Origin and actually stick my head in the rocket that they're designing to take some of the first passengers out in space. And so that one is just a visualization of, I want to see what my trip in outer space is going to be like. In reality, we do more premium selling that's a little bit closer to Earth. We built a design system for Stryker that basically helps them show a surgeon and hospital administrators the hospital operating room or suite of operating rooms that they're going to buy. So this is one where they have premium equipment. They want to show that premium equipment to a client in a premium way that actually makes sense. The real value here is that surgeon cares about the functionality of the thing they're going to buy. So they really want to feel and understand and experience the thing they're going to buy. And I'm going to talk a little bit more about that because this actually overlaps with premium selling and space planning. Soft skills training. So I'm about to go through 4 things that are all education training related. We at first we just thought of them as all being in the same bucket. But what we started realizing, there's nuances of different training scenarios. And I'm going to go through these 4 training scenarios, pointing out the nuances and differences between them. So the first one is soft skills training. For a client of ours, BrainShark, we built a solution where they already have a training solution they use to train the sales force of a company that Microsoft happens to be one of their clients, so they reference them a couple times. So they already use cognitive services to listen to what a person's saying is in a sales pitch. They're feeding it into a cognitive services, analyzing it, and making decisions about whether you said key talking points, whether you are stalling, whether you're talking too fast, too slow. And so what we built for them was an audience that you can actually sell to. So the audience are these avatars, and you're selling the avatars. The avatars will just start looking bored, or they'll start looking confused, or they'll sneeze to try to distract you. So we try to build in a lot of capabilities where they can basically experience something that feels real. And I'm not sure if any of you have experienced a HoloLens solution or any truly immersive solution where you're talking to somebody that doesn't exist except as an avatar. If you combine the avatar with 3D sound, it is amazing how much you feel like they're in the room with you. It is one of these powerful, visceral senses of presence that you don't get from video conferencing or anything else. And this actually leverages some of those capabilities. This one's interesting that other than it does take money to create the content, there actually aren't any big barriers to starting to do this today. Hard skills training. So hard skills training, so that one is about soft skills, like how do you interact with people and how do you read emotions. This one is about I'm learning something in 3D, and to learn something in 3D from a 2-dimensional book, it's just a lot harder to learn. I mean, I've assembled a lot of IKEA furniture. If I was actually able to have it show me in 3D what the next step I'm going to do, I guarantee you I would be able to do it at least 20, 30, 40% faster. So there's a lot of opportunity to teach a 3-dimensional motion skill of your body in 3D so that you can pick it up much faster. This has some of the same challenges as everything else. There is a lot of content creation that has to happen. We're working really hard right now to make sure that content creation is more of an artist challenge and not a technical software development challenge. So educational conceptual learning. So this is about understanding really, really difficult concepts like math around volume, or how chemicals are going to bond in three-dimensional space. There's a lot of conceptual understanding of the world that has nothing to do with how your body's moving, but it has to do with your brain to be able to understand that body of information. So there's a huge opportunity for this to actually enhance how we teach conceptual information in the schools and obviously also in the work environment. This one takes advantage of a lot of the capabilities of the HoloLens. There's a lot of opportunities to effectively tell the story in HoloLens in 3D to just help cement the concepts. And obviously, you can also build in testing as well into the solution. And all of that can feed as telemetry data back to central system. Expert coaching. So this one is yet another twist on teaching. This is from the teacher's perspective. One thing that we hadn't talked about very often with clients is the fact that the teacher has tools too. So this is more about using all these smart clubs and smart balls that are providing a ton of telemetry information, taking advantage of that, making it available to a coach that is trying to teach a three-dimensional skill. And the reason this is a little bit different than the hard skills is that coach has extremely deep expertise in what they're teaching, typically. And you need the coach's extreme expertise to teach some of these skills that you couldn't possibly embody in an automated system and teach 100% automatically. So this is focused on what are all the ways we can take all the data that current generation devices produce to help the coach's side of the equation. Space planning. So space planning, I was mentioning with the Stryker solution that we built. The surgeons care about seconds, shaving off seconds in surgery. If they can move that table just a little bit, and they can actually, it's good enough in HoloLens for you to actually pretend like you're doing a surgery, kind of doing a choreographed dance of the surgery to prove that you're shaving a second off here or second off there. But that's just the tip of the iceberg. There's just so many space planning scenarios about product placement in stores, efficiency, factories. So we have clients that build literally cardboard factory cities. They'll make fake factories out of cardboard and do the same thing. They'll actually walk through it as if the factory exists just to prove that it's a good design. And so there's a lot of opportunity to bring that into something like HoloLens because now you can literally experience something that doesn't exist in three-dimensional space. One of the challenges with this is that a lot of these scenarios, FOV is something you get used to, and it doesn't really matter that much. But there certainly are some cases, especially if you're in an environment where you aren't actually in the device for very long, where the limited FOV of current-gen devices is a challenge. But in something like this, it's really important to be spatially aware of everything that's happening around you. So, I mean, this is all being solved very quickly, but today that would be one small challenge that is faced in deploying this for certain scenarios, especially scenarios where there's motion and lots of things in movement around you, and you have to be spatially aware of a lot of things at the same time. Situation planning. So this overlaps with some other things. Situation planning, obviously there's a lot of defense references to this in sci-fi and in movies, but the real use, well, there's obviously defense uses, but the real uses that I see are, again, we're becoming an IoT-enabled world. Imagine all the security devices across a complex campus of a large company. All of that information is there, but again, you can't necessarily experience it in a way that makes sense. We built a system for surveillance that touches on this for public utilities. Imagine a hurricane comes in, you got public utilities emergencies happening all over. You want to see the Doppler in 3D overlaying so you can make connections between what's happening with the weather. Why did that one fail and not that one? And you just want to see that whole city. It's basically kind of the beginnings of smart city. You want to see everything that's happening in that city three-dimensionally so you can glean insights of what the relationships are between everything that's happening in that situation. Experience invisible data. There's some overlap with this in some of the other things I've talked about. IoT device creates data, but then there's also finite element analysis where you're just analyzing how something would work once you build it. And this bottom example, PACCAR, speaks to that, where they can simulate what the wind is going to do and determine what the impacts of a design will be on its efficiency by seeing the wind and seeing why the wind is building turbulence or reducing efficiency. This one honestly doesn't have any major challenges other than data complexity, getting very, very large complex data sets on the device. But for a lot of these scenarios, that's actually quite manageable today. Or medical imaging. I love this one too. So we are a three-dimensional entity, and everything a surgeon does is almost always 3D in nature, and they're doing it all from 2D screens. They will often literally like scramble. They'll get in there and they'll look at a tumor and they'll scramble because they thought they knew exactly what the tumor was and what its shape it was, and they'll see something that they didn't expect, and then they want to reference all that 3D data again. The best they can do is 2D, so they're very quickly trying to get to the right slice of an MRI to see what is that thing that I didn't expect. And so you can imagine this future where you're able to actually look at the human body and all the data you've collected about the human body in 3D to understand it more comprehensively. So to the extent that you actually want to align with the body, which will happen, Stanford already has been doing experiments with that. They're getting down to like 1 or 2 millimeter accuracy on placement, which is pretty cool. Other than that accuracy of alignment, this is mainly a challenge of, again, data set complexity. And it's worth mentioning that even is solvable today with some small compromises. All right, this is a new one I just identified. I keep looking for new ones, so if anybody ever knows of any that I'm not covering, please email me or find me on LinkedIn. So focus groups, similarly to some of the others, you're trying to get information on something that doesn't exist yet, maybe 3 product designs. Right now, you have to actually fabricate fake versions, 3D print them and paint them, or use 2D mock-ups to get those opinions. But take it to the next level. You can actually, in a focus group, experience something that doesn't exist yet and get much more accurate feedback about how you feel about this one versus how you feel about this one. And of course, it doesn't have to be small products. With today's devices, small products are probably a good place to start, but it could be focus groups around anything that's three-dimensional in nature. There's this opportunity to have a better quality feedback. Remote expert, I won't go this much, it's covered so many different places, but this again is an amplifier. Remote expert can amplify almost any of the other use cases that I've already talked about, because in any one of those scenarios, you may want to use an expert that a company can't afford to have deployed in the field. The experts are in a center, but you want to make them available in a really meaningful way out in the field. And that could be anything. That could be hospital to hospital. It could be call center to elevator repairman. It could be any combination of those two things. That is already a normal pattern in business, and this just makes that particular pattern much more valuable. Some of the challenges here, safety compliance. A lot of this is outdoor and in unsafe areas, or there's OSHA requirements OSHA in the US, requirements to make sure that you're thinking about all of the regulations around having these devices out in the field. Infinite screen, running out of time, so I'm going to keep moving faster and faster and faster. So infinite screen, the idea is that there's a lot of data that you may want. You're limited to your little laptop or monitors, but you really have an ocean of pixels now. How do you leverage that? The first gen will be a lot of 2D, just to bring 2D data in from existing apps. In the future, it'll be a combination of 2D and 3D. The real challenge right now is that the very apps you depend on don't necessarily run on something like a HoloLens or an Oculus or anything else that's out there. So you pretty much have this barrier right now of getting that into there, but that's a relatively small solvable barrier through middle technology that will get solved relatively fast. Almost done. Automated guidance. I have an example of being guided through a museum, but you can also imagine this applies in business settings as well, like a factory where you're being guided. Every single car going to that factory line is different, and so you need to know what it is that you're supposed to be doing on this car, not the next car. But there's obviously a lot of opportunity in navigating your world. Guidance is all about navigation in three-dimensional spaces. This happens in logistics scenarios and in large warehouses as well. Art and creativity. So this is a kind of wide open field. I saw some really, really cool demos in the art and creativity area at Microsoft Build last year, and I'm really excited about where this is heading, but obviously this is a whole new medium that opens up all kinds of new possibilities for having three-dimensional experiences. Entertainment. This one's an interesting one. Venues are a physical space. You may not be able to go to that venue. My dad was wheelchair bound, and he actually spent a lot of time in Second Life dancing with friends because that was his entertainment, and it was really valuable to him. He really got a lot of connection to other people by doing that when he was never able to leave his home. But that's just a small example. There's a lot of opportunity to just enhance existing experiences, to give you bring more of that experience into your environment, into your home, so that you can actually experience it at a much richer level. All right, so I'm not going to go too much into this, but one of the things that we do as a company is try to find all the clever ways that you can deal with a lot of these issues. Like FOV, you use sound and pointers to say, oh, there's something interesting over here. Battery life, if it's really important to, I mean, it's possible to have a pack that gives you extra battery, or you just have two, you can afford two and swap. Safety, Trimble has just released a hard hat that is HoloLens compatible. So a lot of people are trying to solve these, and we just pretty much cleverly try to figure out all the ways in which you can solve these problems. And that's a key part of what value that we're providing to our clients. 11 seconds. All right, so I will leave you with this thought. It's not easy, but with thoughtful design, smart engineering, you can deliver real value. Oh, that was my phone. I didn't know it was going to do that. My apologies. So you can actually, with today's devices, deliver real value. We've been doing it with our clients for the past 3 years. There is value to be found. It's not easy, but I'm really excited about the fact that even today's devices do, and this is just the beginning. Thank you.
Michael Hoffman.
All right, I think there's
several
questions.
We've got like 2 questions.
Yeah.
Like you took it quite seriously with an alarm clock.
Yeah, sorry. Well, I should have known that. I couldn't find it the last time I did.
No, don't worry. The thing is, like, we still have time.
Where's the clock?
No, but because I know we're kind of in the delay, but we're glad that actually the 2 questions came in, and because you were actually replying them. Fadi didn't have time. We wanted to use all of that for his presentation. So going like straight for the first one. Okay. Almost all the use cases you mentioned need high-quality content, which can be both time-consuming and expensive. Isn't this the biggest challenge for adoption?
So there is a large gamut of use cases where that is absolutely the reality. Now, Stryker is a good example of where that's not the reality. Stryker has a fixed set of equipment that they release to the public, and they're high-dollar equipment. So for them to pay a company like us or any number of companies in here to say, I'm going to take that content and make it run really well on a limited device, you can afford that curated set of content for that kind of environment. So it's not across the board. The place where it's really, really hard is, there's this training scenarios. How do you get all the content for a training scenario into there if you're not going to do the training scenario enough time? So this is really more about how often, what is the ratio of the build cost to the deployment value, which grows ever bigger when you're deploying many times from the same source content. So that divides the ocean of current use cases into build once, use many times, and build once and use few times. And that's a good way of looking at where to look for that value today.
And as for the last one, you've mentioned all the benefits of mixed reality. What do you think are the biggest dangers for our civilization? Can it be misused?
Yeah. So this is a really good one. Thank you for asking that, whoever asked that, because I have thought a little bit about this. I think the biggest danger is the very thing that makes mixed reality so powerful. Stereoscopic vision taps into a more primal lizard part of your brain. So if anybody is trying to deceive you or gain trust with you, there's more opportunity to dig deeper into that primal part of your brain and manipulate you at a new level that we've never seen before. And that, honestly, is the biggest concern I have, is that it will empower certain types of people to actually take advantage of the fact that stereoscopic vision is a much more visceral experience for humans.
Well, then, thank you so much for answering this question. Thank you, ladies and gentlemen. Michael Hoffman.